Hello, everybody. It's April 14th. Today, we're going to talk about gravitational potential energy. So we talked about kinetic energy last lesson. Today, we're going to move on to talking about gravitational potential energy. So the difference between the two. And then tomorrow's lesson, actually, it'll probably be the next day after that, we'll discuss the relationship between the two and the law of conservation of energy. Once we do that, we really only have to talk about springs, and then we're finished momentum, work, and energy. So we're going to have some sort of end of unit assessment. For dynamics, we were only able to get that quiz in, so that'll have to do for right now. Beyond that, I've contacted you if I'm missing some ogres from you. If you haven't handed in some ogres, I am definitely missing some. I need you to try to get those in because those are what are going to have a big impact on your marks, just because we haven't been able to do as many formal assessments as we would have. So we'll probably have a momentum, work, and energy little take-home quiz in the form of a Google form by the end of this week. So that being said, we're going to do a problem of the day today. And today is, hold on, I need to open this up. That should be good. Today is Dolphin Day. So that's going to be the theme of your question is dolphins. It's on kinetic energy, the difference in kinetic energy, the change in kinetic energy. Remember, if I'm asking you about work, there's a chance that I could be asking you to find change in energy for me because those two are the same thing. So we're going with a baby dolphin because I initially made this question to have an object that was 10 kilograms, and dolphins weigh a lot more than that. So we'll go with a baby dolphin. A 10-kilogram baby dolphin has a velocity that changes from 15 meters per second to 25 meters per second. What work was done on in this scenario? Okay, so what work was done by the dolphin in this scenario? Pause now. Give it a shot. Remember, we have change in energy is equal to work. And if you paused and tried it out, you should have got this. Work is equal to the change in kinetic energy. That means that we have the final kinetic energy minus the initial kinetic energy. So that's 1/2 mv squared. So 1/2 10 times 25. That was the final velocity squared minus 1/2 10 times 15, which was the initial velocity squared. If we do that, we should get 3,125 minus 1,125, and you should get 2,000 joules of work done by the baby dolphin that we see there. All right. So we have actually got quite a short lesson today. We got 1 page of notes on gravitational potential energy. We should be able to go through it quite quickly. I need to just open up the full screen on the notes here. There we go. And I'll share it with you now. All right. So last lesson we discussed kinetic energy. Today we are discussing gravitational potential energy. Let's do. All right. So what is gravitational potential energy? I generally like to keep to calling it PE, but if you prefer, you can do E with a subscript P. You will see that in the future if you continue on with physics. Some people prefer that notation instead. When an object moves away from Earth, energy is stored in the system as a result of the gravitational force that acts between any object and the Earth. There's a gravitational force, we talked about this, between any two objects. It doesn't have to be a planet and a person or a planet and an object. It can be between two humans or even just two small objects. It's just a really small gravitational force. Now this one is due to the gravitational force that's so large on Earth. So this stored energy is called gravitational potential energy. If I hold this pen up like this, obviously when I let go of it, it's going to fall. There's no surprises there. Okay, but that is because I'm storing potential energy inside of that pen. Potential energy, right, just means literally that. the potential that I'm storing inside of it. It has the potential to release energy. And when I let go of that pen, it then turns that potential energy that I've stored within it by holding it up in the air into kinetic energy because it moves and it moves towards the table. All right, so this stored energy is called gravitational potential energy, and the potential energy can be calculated as follows. P E is equal to mgh. PE is equal to mgh. Let's write out what all of these means. This is potential energy. What do we measure energy in? Joules. Okay, and then you just have mass, acceleration due to gravity, and I guess I should write it all out, due to gravity, and h is the height. Keep in mind that in this one, you want height to be in meters, you want mass to be in kilograms, and you want acceleration due to gravity to be in meters per second squared, right? And then if we look at all of these together, you'll have kg times m times meters per second squared. But that's a lot kind of complicated. We'll just stick with joules. How does this relate to work? Well, we've talked about this various times now. A transfer of energy is just known as work, right? So when the potential energy of an object changes, work has been done on that object. This work can be calculated by the following. It's very similar to what we did in the last lesson. The work is equal to the change in potential energy. So the work is equal to the final potential energy minus the initial potential energy. So PIF minus PEF minus PEI. I just want to remind you that if you prefer, you can use twos and ones. That's the same thing, right? Final minus initial. Note, in this formula, it is assumed that the velocity does not change. So what it assumes is that we're actually not having an acceleration downwards, because that complicates things. So for the time being, we have a constant acceleration acting on the object, gravitational acceleration, but the velocity of the object doesn't change. So what I'm trying to say is for this example, it would have to be like a car rolling down a ramp at a constant velocity downwards. Now, gravity is making it move downwards, but it's not accelerating downwards. Just the gravitational acceleration is what's making it move. But because we're on that ramp, it's moving down at a constant velocity. So for this formula, we have to assume that the velocity doesn't change. So, example, how much work must be done to roll a 1,500 kilogram car up a 10-meter long ramp at a constant velocity? We're assuming that it's at a constant velocity. That is 2 meters high. So something like this, and this height right here is 2 meters. And we'll draw my classic car here. And I've got nobody that's able to make fun of my drawings right now, which is nice. There we go. And we have pushed the car 10 meters. So this is right here, boom, boom, right there. That is a 10-meter ramp. So we've got a couple other important pieces of information. We know that the mass is 1,500 kilograms. That's important. And then we know that what's going to be acting against us is gravitational acceleration, which is going to be 9.8. Now, there's a couple key things to consider here. We have work is equal to the change in potential energy. We know that already. So let's write it out. Work is equal to the final potential energy minus the initial potential energy. Now let's write that out one step further and break this down into its formula that we see up here, mgh. So the mass of the object's not going to change. Gravitational acceleration is not going to change. But what is going to change is its height. So we're going to have mgh2 minus mgh1. Over here, let's write down what is its final height and what's its initial height. Well, its final height is at the top of this ramp, and the ramp is 2 meters high. So its final height is 2 meters. But what was its initial height? At the bottom of the ramp. It's just 0. So its initial height is 0. So what that gives us then is that initial height here is going to be 0. So this whole one right here is 0. Makes our life a lot easier because now we only have to look at mgh2. So m being 1500, as we said before, g being 9.8, and h2 being 2.0. So that's it. We just need to multiply all of those together. Work is equal to 1500 times 2 times 9.8 should give us 29,400 joules. So that is the amount of work that is done to move that car up 2 meters along that ramp. So on inside of your homework booklet, you should have some kinetic energy and gravitational potential energy problems that you can work on. And not tomorrow. We're trying to do every second day now, just to give everybody a little bit more time to be able to make sure that they are caught up and keeping up. So not tomorrow, but the next day we'll move on to the law of conservation. If you have any questions on the homework, let me know. You can email me or you can put comments on the Google Classroom or on this YouTube video. All right, we'll talk to you later.